Okay, so we will be starting with selection sort today. So it's a different kind of algorithm. So first we will take two arrays here. Say mm, this is array 1 and this is the sorted array. This is the result and that's the input with the output. Okay, let's say 4 elements and make some bigger array to keep it clear. See, trophy. Yeah, yeah. Okay. So let's see we have two array. This one is the result and this one is the input array. So say input. This one is the output array. Okay. Now what we'll do, let's say this array elements has elements 8, 11, 2, 6, -1, 4 and 39. Okay. Now what happens is that after taking the input array, we define one variable. So keep this in mind, we define one variable called min. Now this min variable is the key for selection sort. Min, minimum, anything you want to name the variable, we define a variable. So initially, this variable stores the minimum most element in the array at every stage of the iteration. Okay. So what do I mean by every stage of iteration? I will just name the indexes 0, 1, 2, 3, 4, 5, and 6. So we have 7 elements. So the iterations are from 0 to 6. So we will run every loop from 0 to 6. Okay. So what will happen here is that first in minimum I will put 0. It contains the index of the minimum element, the most smallest element in the array. So let's consider 8 is the most smallest element. Although I know -1 is, let's keep it 8. Okay. So let's first keep 0, means 8 is the smallest element, so we will keep 0 here because 0 it says index. So we start with by keeping 0 in its place. Okay, where is that pen? 0. Okay, now this is 0. Now in the first iteration what I will do, I will compare this, the element stored in minimum, with each element of the array. So when I go to 8, 8 will be checked with 11. So 11 is still uh, greater than minimum. So in minimum, the value of minimum, m of minimum, suppose this array is m, then m of minimum is still less than m of 1. So it will remain the same. Okay, then we check for m of 2. The m of 2, the index is also 2 and the element is also 2. That's a coincidence. Okay, now m of 2 is less than m of min. Okay, is less than m of min. Then what we should do, we can say that now min is equal to 2. Okay, so now this is a min element. Now I will remove this circle from here, and so we have the circle here now. So this is our it is 2 is the index of our most smallest element for now. Now next this moves forward, and we start from we compare it with 3. Now m of 3, now the value of min is 2. So m of 2 is 2 and m of 3 is 6. So m of 3 is still greater than m of min. So the value of min will not change. Okay. Now again we will compare it with m of 4. Now m of 4 is less than min. M of 4 is less than m of min. Min is the index. Okay, min is the index. Now index, currently that index is 2, which contains 2. So -1 is less than 2. Now the thing is that this will become the min element. So what is the index of a current min element? That's 4. Okay, so this is a min element. Now this is the index of min. So min is 4. Okay. So we'll delete these all. Okay. So this is our current result for min. Min is equal to 4. Okay. Now, as you could see, it's quite evident. If you compare min with 4 with the element at the fifth position, if you compare the element at the min position with the element at the fifth position, obviously it will not get replaced since 4 is greater than -1. And same goes for 39. 39 cannot replace the min because it contains -1, and this contains 39. The fifth and sixth position cannot be replaced, but we will also check that, and on checking that we see it cannot replace. So finally, after one iteration, what we get the value of what do we get as the value of min? We get min is equal to 4. Now what we will do? We will say that now we will swap the position we started with. Suppose the position we started with was 0 and we reached here, so we will swap them. So we get one thing to know, that this also has 0, 1, switch this off, 2, 3, 4, 5 and 6th place. So we now we know one thing for sure, that in the sorted array this first position will be backed by -1. Okay, this first position will be backed by -1. Okay, and for now here in the fourth position we have got 8. I'm not saying this 8 will finally be here, but it can be replaced because we are now going for more iterations. So this iteration, what was particular about this iteration? We started with 0. Now we will start with 1. Okay. So now let's replace things here. Let's say now here in this next iteration where we'll be starting from 1. Now we will be starting from 1, and for this iteration here 0th position is -1 and 4th position is 8. Okay. Let's again switch to white. Okay. So as you could see, now in the min position, we will start with 1. Earlier we started with 0 in the previous iteration, now we started with 11. Now we will bring this was the smallest value, it is in the first position. Now the second smallest value should be in the second position according to ascending order. Okay. So now we'll say that 11 is compared with 2. 11 is compared with m of 2. So m of 2 is obviously less than m of min. So now min is replaced with 2. Okay, now then m of min, which is now m of 2, which is 2, is compared with m of 3, which will not replace the value of min since it is greater. Same goes for 4, same goes for 5, and same goes for 6. So finally, in this iteration, we bring the second smallest value at the second position because we replace them this with this after the end of the iteration, because even after the end of the iteration this value min will remain as 2, and since we again replace it with this value which we started with. Okay, so this will go 2 and 11 will come here. I'm not saying 11 will remain here. Let's which have confirmed their spot, let's mark them with white, and let's mark this unsure elements with green. Okay, so this 11 is here and this 8 is here. Okay, and now let's go for the next iteration. Let's remove these markings. Now here we will have 2 and here we will have 11. Let's mark this as also with white. Okay, now in the previous iteration we started with 1, so now we start with 2. Now 2 is now the main value of min is initially 2. Now it's compared with element at 3. So we can say easily that m of 3 is less than m of min. So the value of min will be replaced by 3. Now again it will be compared with 4. So m of min is greater than 4. M of min is still less than this 8. Okay. M of is less than 8. So 8, this 4 cannot replace 3 because m of 3 contains 6 and m of 4 contains 8. So it's greater. But m of 5, as you could see, m of 5 is less than, because now what we are doing, we are replacing the third smallest at the third position. Okay, that's what we are doing. So 5 is less than min. So what do? We say that this is the element of min is equal to 5. Now what do? Since m of 6 cannot replace min, but we will still check in the iteration, but we know logically it cannot. So after this iteration, what will the value of min sustain? It will sustain 5 here. So the element at position 5 will be replaced at element at position 2. So it will be swapped. So this will now contain 4 and element at position 5 will contain 11. Okay. So now, as you could see, we can remove 11 from here. Okay, so 8 is still unsure, but you can say 11 is quite sure because 11 is the second largest element and largest element is 39. So 39 will still remain here, if I could say. But let's keep 11 also till unsure only, because let's follow the full iteration. Hmm. Okay, now since the previous iteration, the value of min started with 2. Now it will get started with 3. Okay, now this has, now let's see what the updation is. Now this has 4 and this place has, sorry for using the green for 4, 11. Now as you could see, the array is already sorted by now, but still I will just explain one or two iterations more. So now we will start the value of min with 3. In the earlier iteration we started with 2, we started with 3. So now we start with 3 and we compare it with element at 4. It will not be the value of 3, the value of 6, the value at 3 index is less. So 3 will not get replaced by 4. Same goes for 5 cannot replace, 6 also cannot replace. Now again, they will remain as it is. So 6 will remain here, that's for sure. That's the fourth largest element, fourth smallest element remains in the fourth position. Now again, the value of the value of min will now start with 4. So element at the fourth position cannot be replaced by the element with the fifth position. Fifth cannot replace min because the element at fifth position is greater than the element at the min position. Again same goes for 6. So it will remain as it is, and finally the value of 8 is here. Okay. Now again, the value of the 11th position will be here and the value of the 39th position will be still be here, because 5, suppose if we take min as 5, suppose if we take min as 5, so what we will do is that the value of the sixth position cannot replace the value of min because the value at the sixth position is greater, so it will remain as it is. Now again goes for 6, nothing can replace it because it cannot be checked with anything and it was still there, so it's the largest element. Okay, so this is the final array which we get. Now how we will code it? Okay, so after understanding the explanation of selection sort and its working, now let's get into the coding part. So here, as you could see, I have taken the size of the array, defined an array, and taken the elements. Now we just need to sort. Okay, so the best part, so the most important part of this sorting technique was first to take a variable minimum. So we'll just define it here. We'll say minimum. Okay, apart from that, so I will have to say int minimum, and then I will have to say j, and since we will be swapping, we will be needing a third variable temp. Okay, if you know swapping method, you need a third variable. Okay, so j is for the nested inner loop of the nested loop. Okay, now we will get to know how we use them. So the very first step will be, I will be starting a loop as we do in all, whether it's sorting or sorting. One step is quite constant for every array operation is that we need to make a loop from I to from 0 to the end of the loop, end of the array, which is I0 to n. Okay, now here what I will do, I will say min is equal to I, because as you could see after each iteration when our array is sorted, the value of min is moving forward. It started from 0, then for the next iteration it moved to I1 after swapping. I mean after swapping, not just between what we do, we don't, not like that. We start, the starting value of min gets incremented by 1, like 0, it started from 0, then 1, then 2, then 3. If you stay focused on the theory explanation part, you will get what I'm saying. Next, what I will do is that I will say for j loop. Now when, if you see, if we say min is I, if suppose we start from here, as we know we started from here, then the checking portion was started from here, suppose from this portion, where if min is the element at the 0th position, then we start comparing it from the element at the first position. So we will have to say if min is I, then j should start from I plus 1 and go on till end of the array. Okay, so suppose min starts with 0, the value of min will be initially be 0, so it should be compared with all the values from I plus 1, which is the 1. If I value is 0, then I plus 1 is 1, to at the end of the array all elements should be compared. That's why we are starting from I plus 1 to n. Now since we are using I plus 1 here, so if you think by yourself, when we reach at this position n minus I, when the value of I is 6, okay, so if I say I plus 1, it will become 7. To avoid that, we will write n minus 1 here, so that using, because of which I loop will stop till here, and this will automatically be compared when we say I plus 1. Okay, I hope you get this, why we did I n minus 1 here. Okay, next what we will do, we will say inside for j loop, we will check if m of j, means suppose taking the first element into consideration, suppose this was the first element initially, 0, 1, 2, 3, 4, 5. Okay, so if m of j, so the value of min is 0 and m of min is 5. Okay, quite good, right? The value of min is 0 and m of min is 5. So as you could see, what I will do, that m of j, if m of j is less than, so what's the first value of j which will be coming here, m of 1. If m of j is less than m of min, then I want to replace the value of min as j. Okay, so first this whole loop will run and then the value of I will be increased. So let's run this whole loop. So how it will run, so the value of min is 0 and m of min is 5, as you could see here. Okay, now we start checking it from j, the value of j will be I plus 1. Okay, so m of min, which is 5, will be compared with m of j. J is 1. If I is 0 at the very first iteration, then j value will be I plus 1, which is 1. So 6 is not less than m of min, so it will, the value of 1 will not replace min, means this index will not replace min. Then same goes for 7, it cannot replace since it's greater than the value located at the min position. Then again it will not, 13 will also, but when we reach 2, it will replace the value of min as 2. Now again the value of min now, which is now 2, m of, so the value of min here will be not be 2, it will be 4, because we are replacing it with the index. At m of 4 we found 2, which is less than m of j, which was initially 5. So the value of min will be this index here, the index of 2 is 4. Now this m of min is now 2, it will be compared with m of 5, which is 11. Now 11 is greater than 2, so it will not the value 5 will not replace min, so min value is 4. So here we get min value as 4. Now after that what we will do, if we say now, say after coming out of the j loop, we say if min value is not equal to what it started with, if it's not equal to what it started with, then we will swap. Now swapping is simple, like we did in bubble sorting. We say temp is equal to m of we'll say m of min sorry, m of I, then m of I will be equal to m. I was 0, I is still 0 na, so I is 5. Okay, so m of I is this position, m of I is this position. Okay, so I have stored the value of 5 here, and at m of I now I will bring this value which I got in, which is in the min position, which is in the updated min position, which is 2. So 2 will come here, and what will happen? In the m of min position, the value of temp will go, means this 5 will come here. This way swapping will happen, and when it will happen, only when the value which we started with, we started with 0, then there was no need, if there is no need to replace, if after iterating through or after traversing through whole array, if there was no element found which is smaller than uh, this the element present in the min position, then there is no need for swapping. If suppose this 2 was not there, some other number which is greater than 5 was there, so it would not have swapped. Okay, so that's why this if statement is important. Okay, now this whole iteration finished. Now here we have 2. Now here we have 2 here, and here we have 5. Now again there will be I plus plus, and the value of min will this time start from here, from the first position, because I is equal to 1, and j will start from 2 to 11. J will be starting with, j will be going from 2 to 11. So value present at m of min, means which is m min value is 1, so, and the value present at min position is 6. So 6 will be compared with 7. No, it's still less, so value of min will we stay there. 13 goes for same. When it reaches 5, again the value of min will be replaced by 4. Why? Because the element present at the fourth position is less than the element present at the sixth position. So what will happen? This both will swap. Okay, again we will move forward, and here it will be 5, and here it will be 6, and that way at every iteration the array will get sorted, and hence we will get the finally sorted array. Okay, so now after this we will print for I is equal to 0, I to n, I plus plus, printf percentage d m percentage, and we will print m of I. Now let's execute it. I gave the wrong array. We'll have to give 6 positions. 5, 6, 7, 13, 2, 11. Let me format it properly. I think it worked. 6 positions. 5, 6, 7, 13, 5, 11. Here it should have been 2. Okay, but as you could see, the sorting worked. Okay, so I added 5 two times, so 5, 5, 6, 7, 11, 13. Okay, so it worked, and that's all for the selection sort. Um, Thank you.